this should be similar to what you're going to do when you're going to make a function. A function hides the idea of how expressions work. It's going to have methods like eval and constructor. Let's make a constructor here. Let's call this. Can I duplicate? No. Copy. So a new class here called funky list. All right, we got our funky list. So I want it so that when I create a funky list, I get a random list.
This factory.
The list factory? List factory dot
Random list.
random list.
You have to put a 0 in there?
And you got to put a 0 in there. And then we can also make another constructor where if I give it a list, it just uses that one. Funky list. Yeah. New. Funky list. What am I going to get?
Random.
Yeah, can't type string. Yeah. Let's make a new funky list. All right. Let's go funky list h equals new funky list new singleton. h.toString, what's it going to give us? 5. Okay, so I can either say, if I create a funky list, I get a random list, or if I give it a list, it just uses that one. If I go h.add 20, can I do that?
Yes.
Should be able to now.
Yeah, and if I go h.toString,
Should be.
25.
25. So I can kind of give it a list to start with, and then I can keep doing methods on it. Okay? So if you look at the assignment is you have a function class, it has a constructor. If you give it no arguments, it generates a random expression. If you give it an expression, it just uses that one. And then it has a method called eval, one called toString, one called count, which is kind of like size, and one called plot. And for plot, should be able to take the plotter class that I did last time and just kind of drop it in. What you'll do is you'll just instantiate a plotter class, pass in the expression you want to, the function that you want to evaluate, and it just plots it.
Is that on Canvas?
Yeah,
When's it due?
in a week. All right, so I've already posted. Let's go here. So you've already got the expression interface, the value class, the add, the multiply, and the plotter. So you're going to be adding on 2 new binaries, 1 unary, and a function class, which is kind of like the funky list, and then integrate it with the plotter. All stunned.
Seems fine.
I've shown you 9% of it. But it's gonna be kinda cool, cause you'll just say, generate a random function, plot it, and it'll be like, all sorts of stuff on the screen. So our goal, eventually, is be able to, did I show this to you last time? I showed a couple people. We would set up an arena.
I don't think you showed this to all of us.
I showed it to all of you?
No, you didn't.
No, so we're gonna set up an arena, and there's gonna be a little robot on there, triangle, initially facing maybe to the right, and a target. And we want it to get to that target
As quickly as possible.
as quickly as possible.
Okay.
So what it's gonna do is it's gonna take one step forward, and then it's gonna evaluate the expression, the random expression. And that number is gonna return some kind of number, and that number is gonna be how many degrees to turn. So it'll take one step forward, and then turn according to what that function tells us to turn. So let's say that function returns 12, so it'll turn 12 degrees. And then it'll take a step forward, and then evaluate the function. But the number we're going to pass in is how many steps we've taken. So the first time we're going to pass in a 0, second time we pass in a 1, then a 2, then a 3, and so forth. And what's going to happen is this thing is going to wander around. And we'll say, take 1,000 steps, and then see where you end up. Then we'll measure what was the closest you got during your walk. We'll do that 100 times, so we'll have all these little guys that are randomly walking around, and we'll figure out which one came closest to the target. Take the function out of that one and use that to kind of clone 100 new robots that all have similar expressions. So we've got some expression tree here. We'll take some of it, maybe we'll replace this with another little expression. Maybe we'll swap these around. We'll just randomly change some of these numbers. But it's going to be based upon the one that got closest. And then we'll do this 100 more times, and hopefully now we'll get robots that are all kind of like wandering in the same direction. See which one came closest, do it again. And then hopefully, after doing that a few dozen or 100 times, we'll get a robot that goes right to that point there. But nowhere did we teach it how to do that. It found out how to do it. That's cool. But then we take a step forward. And we put another target on there. Now it's going to hit both of them. So the function can't just be turn and go straight.
So that's gonna be easy.
It's got to be turn, go straight, and then take another turn. Or something like that. So we'll have to figure out how close did it get to both these targets.
Do we get to choose where the targets
Yeah.
are positioned?
But initially, we might stick them in the corner, something like that. That's where we're going.